We'll start with takeoff here. So this takeoff roll is about 3 seconds long. Looks like takeoff occurred at approximately 15 meters per second. And then immediately you can see we sort of got big oscillations in all three axes as I try and get this thing under control. Here's where I start to first encounter that sort of roll instability that I was feeling. The red line here is the roll rate, and then the yellow line here is the yaw rate. So here you can see, like, I mean, maybe it is actually out of phase a little bit. You can see here that the roll rate increases, and then the yaw rate increases at the sort of peak of the roll rate there, and then as the roll rate transitions to negative, the yaw rate peaks, and so it's sort of 90 degrees out of phase. And I think this happened in a turn, which is why the yaw rate is offset positive, but yeah, maybe there is a bit of Dutch roll going on there in the Maiden Flight. So if you look at this number down here, this is sort of the commanded roll input, and so if it goes positive, you expect the roll rate to go below the line, and then if it goes negative to this side, you would expect the roll rate to go above the line. So you can see here that I'm actually commanding positive, and it goes down, and I bring it back to neutral, and then here it does go back a bit. I'm just dead center on the stick. I'm not having any roll control input, and it's actually rolling back to the other side. And then I give it some more to the one side, and so it comes back down, and then you can see I'm pretty much neutral, if not going back down, and you can see here it's still returning positive. So I think there is a bit of maybe a Dutch roll phenomena or a wing rock, especially at higher angles of attack, that is present. So this right here is that spin that we had. I'm gonna rescale this just so we can get an idea of what happened. So about there you can start to see the extent of the data. So we were actually fairly close to stalling, I'm pretty sure here, because we're looking at like 1.5 G and we're at, what's the airspeed, like 18 meters a second. So if we look at the VN diagram for the Maiden Flight here, zoom in on that a bit, this is your load factor in G right here, and then this is your airspeed. Now this does include like a bunch of post-stall stuff, so this isn't entirely accurate here. The actual boundary of the flight envelope is probably going to look something like that. But you can see that 1.5 G at 18 meters a second is probably close to the end of the flight envelope there. And maybe if you get a bit of asymmetrical stuff going on in some wing rock, you get basically what happened here. So you can see roll rate is like immediately up to close to 2 hertz, like 600 degrees a second there. The accelerometers, it goes, I think it actually goes negative here. I think this is an inverted spin, which means that that lift coefficient would be even lower, so it would spin easier inverted. So you can tell it's a spin because the yaw rate is consistently negative at about 170, 200 degrees a second there. And you could look at my control inputs here during this whole thing, and I think I was countering with aileron, but I wasn't, you'll notice I wasn't countering with any rudder because I didn't quite exactly know that it was a spin. Basically what I saw was that it rolled on its back, it rolled once or twice, and then the nose just gradually sort of fell down. And this thing is probably fairly nose heavy, so an actual spin would be hard to distinguish from it just corkscrewing while going downward. So that's something I definitely could have done better, is actually put in some opposite rudder. Although it's a bit hard when the airplane was as far away as it was, and it didn't quite actually know what was going on, so it didn't know the proper control inputs. I do remember adding power though, or at least adding power at the end of it here, you could see, or at least keeping power in it just so I'd have some airspeed to get out of whatever happened. But if I had gotten too close to the ground, I would have cut power and held full back elevator and probably just put it in. So we were pulling some big G's, big negative G's here. So got to 3.3 G's there, peaked around 5.8 G's there. So yeah, we were pulling some pretty serious inverted G's there. And then during the recovery here, you see maybe 3.5 G's, probably close to that edge of stall for what the airspeed was there. And just more of those roll oscillations coming out of it as well. This was one of the sketchier parts of the flight, definitely. So here's one of the real big wing rock incidents. As you can see, the yaw rate is lagging a bit behind the roll rate here, but it's not too much. And then if you see my inputs, I'm putting it in to go down, and then I push it in to go up here, and then I don't push it to go back that way, but you can see that I'm actively aggravating this cycle here. I think what I'm dealing with here is it's actually part pilot induced and then part some sort of Dutch roll combined with wing rock phenomenon that I'm dealing with. And you can see here I'm pulling like 4G at 27 meters a second. So if you look at our VN diagram, 27 meters a second around here, 4G. So yeah, we're like right up here. And that's probably fairly close to the edge of the flight envelope there. So I could definitely see this being very close to stall and wing rock territory. I've never had any pilot-induced oscillations that happen on anything other than just pitch when you're going into flare to land. This is something new that I have not experienced, oscillations induced by the pilot on roll. And this plane just had a ridiculous roll rate, which is probably why it happened, coupled with its other tendencies. So you can see here, I'm just pushing the stick that way, and so it goes down, and then I push the stick the other way, and it goes up. Then I push the stick back the other way, and it goes back down again. It's like I'm telling the airplane exactly what to do. And you can also see here that, again, this is at a high load factor, at a relatively low airspeed for that low factor. So maybe it's the condition is aggravated when you increase the angle of attack and get close to stall. Anyways, the rest of the flight is just more of the same. You got all the go-arounds and stuff that I did. And then right around here, this is the final go-around. So if we take a look at our battery statistics here, I'm at 100% throttle, and I'm pulling about 39 amps, and the battery is at 18 volts, so it's all the way down to 3 volts per cell, basically. And that amperage just continues to decrease, not enough power to stay in the air, and eventually I just end up putting it in, because didn't have enough power to maintain flight. And if you look here, sort of on the transient, we got up to like, I don't know, you could call that like 15G here. And you can see that my control inputs were actually not helping the situation. If anything, I was helping the aircraft roll in. You can see the roll rate here just increase and then decrease here as I put in more to actually roll the aircraft into the ground, which is not the correct thing to do. You can see I was at full power, giving it a bit of opposite rudder too, but that didn't seem to help much. Second flight is pretty much the same envelope, a bit more tame on the G's, not any excursions from the real flight envelope, keeping it out to about the same speed, same top speed. That looks like a 2.5 second takeoff roll, maybe like 2.6, 2.7 seconds. And if we look at our statistics, we're pulling 77 amps at 23 volts, so it's like, 17, 1800 watts, making plenty of power. Somewhere in this flight is where I did my a sort of quick test roll. All right, yeah, here it is. So this was just like a little sort of blip in the roll, right? So we pushed the aileron out to fairly close to its maximum, and then the roll rate we get out of that is 720 degrees a second. So we get 2 hertz roll rate out of this thing at what airspeed? 26 meters a second, and we get 2 hertz roll rate out of it. And for comparison to what that actually looks like, this is some roll rate data from the Efflux Mark II. This is your roll rate in degrees per second versus airspeed. In this airplane, the Efflux Mark II was like, that thing would roll super, super fast. A cool thing about this data too is that you can see this linear trend here. Basically, if you get the roll rate fully developed, you can see the roll rate increasing from the bottom here and going to the top. What will happen is that the airplane will complete one roll in the same distance, regardless of what speed you're traveling at, which is what the slope of the lines here is. So the Efflux Mark II completed 30 degrees of roll in 1 meter when rolling at its maximum rate. And so the faster you flew, the faster you rolled. So if we go to like 25, 26, and we go up here, so that's 700. So it's like right in line with the Efflux Mark II after I dialed it down. And I dialed it down even further for the second flight. So this thing just has a absolutely ridiculous roll rate. And on that first flight, it was just way, way too much. And so I think that's why I got into some of the pilot-induced oscillation. I've just never flown anything that had that high of a roll rate before. Combine that with what looked like some Dutch roll and some wing rock tendencies at higher angles of attack, and you get the sort of behavior that manifested itself during that first flight. I should mention also that I had 50% expo in all of my control surfaces. So roll, pitch, and yaw, all 50% expo, and that still wasn't enough. So here's one interesting thing on the Re-Maiden flight here. This is where that one canard started to flutter, and I heard it, but I didn't actually see it until it started doing it more during the next flight. So we zoom in on this, you could actually see the frequency here on the roll gyro. You can see it's all clean, nice and clean looking, and then right about here it just transitions and you get this just noise in the roll gyro from the canard just vibrating itself really, really hard. And one cool thing about the software here, this is iNav Black Box Explorer, is that you can actually pull up a FFT of this real quick, and it'll actually tell you where the signal is. Now, there's not enough signal in this flight, but we'll look at it during the next flight, and you'll see a peak here at around 40 hertz. And so this flight, the remainder of it was fairly routine. There wasn't anything too crazy that went on. And then finally, we can look at the second flight, or I guess the third flight, but the second sort of official flight after the Re-Maiden here. So that takeoff roll was only 2.4 seconds long. That's a pretty fast takeoff roll. And on that takeoff, you can look at the acceleration in the X direction. We start off the peak probably around 0.95, 0.96 G, and then as the drag builds and the thrust might decrease a little bit, you can see the acceleration gets decreased. Rolling resistance increases too. You can see the acceleration in the Z direction jumping up and down from all the bumps we're hitting on the runway and stuff. So this one we didn't get up to any crazy speeds, but you can see here this is where the flutter starts in the canard. So we got normal, and then you can see it in the roll, and then a little bit in the yaw as well if we zoom in there. So you can see it's definitely in the roll. You got this sort of jagged, rapid oscillation going on. You can see it in the yaw here, and then you can also see it in the Z accelerometer. Pretty sure my sampling is just barely fast enough because I'm pretty sure each one of these points is just another data frame. So it's just fast enough to capture this this noise in the data here and to get a good frequency read on it. You can see that small blip in the FFT, probably like 45-ish hertz, and you could probably pull it up in the yaw channel here too. Maybe you could see there's maybe a little bit in there. Pull up in the Z channel acceleration, you can see it's there as well. We've got this you can see it all throughout this. It's fluttering a lot, and then it goes away a bit, comes back here more, and then this pretty much is, yeah, the canard has completely failed at this point, and it's just completely fluttering. And it does this pretty much throughout the remainder of the flight. Anyways, that's the extent of the data that I've been able to derive from these first couple test flights. I'm hoping to get it back in the air soon, but weather isn't looking too good, so whenever that happens, I'll get another video out showing finally getting to expand the flight envelope, go for max speed, max G, that sort of thing. And until then, I'll see you all next time.